Project, presented by Nicholas Cha. Part 1, Introduction, Research process. Let me share my research about the Fibonacci sequence and the golden ratio, one of the mathematic patterns I found in nature. In nature? Yes. In sunflowers. Sunflowers are annual plants. That means that they only bloom in one season specifically. They look somewhat like giant daisies. They have bright yellow or brown petals radiating from the center of it that ripen its head with seeds. Why is it called sunflower? Sunflowers got its name because the flower turns towards the sun. During the day, these sunflowers face the east where the sun rises, and when it sets in the west, it looks back to the east again to look at it rise. They like to look at the sun all day long. Before I continue about the pattern found in nature, let me introduce the Fibonacci sequence and the golden ratio. Fibonacci sequence. The Fibonacci sequence is a set of numbers that starts with a 1 or a 0 followed by a 1, in which each number is the sum of the two preceding ones. 0 plus 1 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 5 plus 8 equals 13. 8 plus 13 equals 21. 13 plus 21 equals 34. 21 plus 34 equals 55. 34 plus 55 equals 89. The golden ratio. The ratios of the sequential Fibonacci numbers 2/1, 3/2, 5/3, etc. approach the golden ratio. In fact, the higher the Fibonacci numbers, the closer their relationship is to the golden ratio, 1.618. B. Part 2. Mathematic symmetry. What types of symmetry is a sunflower? Let me show you two interesting types of mathematic symmetry in sunflowers: bilateral symmetry and radial symmetry. Bilateral symmetry is where you can split the sunflower in half and it will mirror on each side. Radial symmetry is if you can spin the sunflower and there is the same amount of petals and they look the same on each side. Part 3. Fibonacci sequence in sunflowers. According to the National Museum of Mathematics, aka MOMAT, the sunflower seeds patterns contain many spirals. If you count the spirals in a consistent manner, you will always find a Fibonacci number. Let's count how many spirals in this pattern. 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, 34. 34 spirals. Is 34 a Fibonacci number? Yes, it is a Fibonacci number. 20. If you do the same thing with this one, in the other direction is 21 spirals. Is 21 a Fibonacci number? Yes, it is. This is all reference to momat.org. Now you know how to count the spirals. Let's count the spirals in a real sunflower. Now you know in one direction. 34 spirals. Is 34 a Fibonacci number? The answer is yes, it is. Now let's count the spirals in their other direction. 1, 2, 3, 4, 10, 20, 30, 40, 50, 55. 55 spirals. Is 55 a Fibonacci number? The answer is yes, it is. We have two Fibonacci numbers, 34 and 55. What will you get if you divide 55 by 34? 1.618. The relationship is the golden ratio, 1.618. Now you know when you can find Fibonacci numbers in the sunflowers. Isn't it fun? Part 4, Quizzes and Quests. Which types of symmetry you could find in this sunflower? Can you find out what are the Fibonacci numbers in this sunflower? Do you think you can find the golden ratio like this in the sunflowers? Well, next time you find a sunflower, try to find these answers yourself and have fun with mathematicians' problems, patterns, sunflowers in nature. Thank you.